In this video, we're covering the acetoacetic ester synthesis. This is a great way of making substituted methyl ketones, and we'll get into the strategies and the details of the reaction. So in general, this reaction is aceto is the group in black, right? Only counting the acetocarbons, which is carbons 1 and 2, right? That's the aceto. And the acetic acid is this component, which would be 3, 4, and 5. And it's the ester of that, right? So that's where we get the acetic ester from. And in its simplest version, single alkylation, what we get from this is first deprotonation in ethanol. Second step is going to be the alkylation of that enolate, and I'll use a simple alkyl bromide. And the third case, we're going to do a hydrolysis. We'll do first a base hydrolysis to give the carboxylate, and then we're going to treat this with acid in water and heat it to invoke decarboxylation. And what we're going to get from that is where these carbons come in here, and let me just draw this in blue because these pieces come in this way, the 3 carbons of that. And we're also going to generate carbon dioxide as a gas in this reaction. Okay, so you can see what I've done is I've taken a simple methyl ketone and put a group on the outside of it. So this would be the single reaction version, single alkylation version, and the double alkylation version would look like this. What we're going to do is we're going to alkylate as we did before. I'll do the exact same alkylation in this one. So we're going to do alkoxide in ethanol to do the deprotonation. The second one, I'll use this bromide again to do the alkylation. Now I'm going to do a second alkylation. So I'm going to treat it again with base, followed by a different alkyl halide. In this case, I'll use this bromide in green, and then I'll hydrolyze it with hydroxide, followed by acidification and heating to do the decarboxylation. And what we're going to get from that is our methyl ketone, our acetone component. In blue, I'll have the 3 carbon piece that I put in here, and the other piece is this that's going to go on in green, and I'll have the CO2 go off as the gas. So what we're going to do is we're going to go through these reactions. We're going to go through the mechanism of this so you could see where all these pieces come from. All right. All right, so let's start out with the starting material. All right, the very first thing that happens is the protons between the ester are acidic. I'm going to use a base, ethoxide. I'm going to use a base that's related to the ester that I have here. All right, so I have an ethyl ester. I'm going to use ethoxide as the base, and I'm going to use ethanol as the solvent. So the very first step with this base is going to be deprotonation of this to give me the anion. So I have a stabilized enolate here, and there are a lot of resonance structures for this molecule. We'll draw all those as well. And what we're going to have is, we'll just show the possible resonance structures. All right, so I got a stabilized enolate. The more resonant structures I have, the more stable it is. And then we're going to do the alkylation step. So I'm going to alkylate using this bromide. And what's going to happen is an SN2 displacement. So I'm going to attack here. I'm going to kick out the bromide. And what I'm going to get from that is the alkylated product. Okay. I'm going to do the hydrolysis next. I'm going to react this with OH minus. And when I do that, it's going to add to the carbonyl. And I wind up with the oxide at this point, and I've just formed this bond with the OH, and I still have my alkyl group on. And what's going to happen is this is going to come in and kick out the ethoxide ion. And when we do that, we get this is going to be the part in black, and I'll give away ethoxide ion, which is going to deprotonate this. And don't forget the alkyl group. It's tough switching between colors like this, right? And I'm going to wind up with the carboxylate ion. Right, and ethanol is the byproduct. Okay, we're then going to treat this with acid. And the first thing that's going to happen is just simple deprotonation. So we're going to wind up with a carboxylic acid. If you remember when we covered this section, when I have a carboxylic acid that's in the beta position, this is alpha. That carboxylic acid is beta to another carbonyl, right? So if this is the alpha position, the carbonyl is beta to it, so the carboxylic acid is beta. These are prone to decarboxylation. And what's going to happen is, I'll redraw this. Let me redraw to put it in the correct orientation to do the decarboxylation. All right, so now we're set up to do the decarboxylation, and I wind up generating carbon dioxide and the enol form of the ketone. And in blue, I'll have that. I'll generate my CO2, which is a gas that gets blown away, and the enol tautomerizes. And I'm not going to draw the tautomerization in this video, but you should review this reaction. And that's going to give me the alkylated ketone. So you can see the two parts, the methyl ketone portion of the molecule and the group that I brought in. So if I look at my acetoacetic ester, right, these are the three carbons that are in the molecule here, right? And the alkyl group comes in on top of that. So we need to be comfortable looking at these types of ketones and seeing what bond I could form. This would be a bond that would be formed from that reaction, creating a bond between the 3-carbon piece, and this bromide also has another 3-carbon piece. I'll draw these as squares. That comes in as part of the alkylation reaction. All right. So this is with a single alkylation. The only difference with the double alkylation is once I get to this ester stage, I have another hydrogen that I could take off and do an additional alkylation. And that's what we did in it. So the fact that I could do this twice at this carbon is important for the for the other example. All right, so now what I want to do is just give an example of this reaction start to finish so you can kind of see it within the molecule. So I just draw a molecule like this. All right. And what I want you to do is make this using, all right, so we'll show a retrosynthetic analysis where I'm starting with the acetoacetic ester as our starting material. So I know that these 3 carbons are a part of the molecule. This piece gets blown off as CO2 and winds up eliminating, and I hydrolyze the ester off in the hydrolysis step. So I need to find those 3 pieces, all right, those 3 carbons that I've drawn, and they're right here, here, and here. So the bonds that I'm forming in this reaction are this one and this one. And these are going to both be brought in as alkylation steps. All right, so to start off, I'm going to start out with the acetoacetic ester. And the very first step is always doing the deprotonation. So I'm going to make the enolate using alkoxide. And in my second step, I'm going to do an alkylation. And we'll do this one first, and we'll do this one second. So this piece is a 1, 2, 3, 4 carbon piece. Let me actually do that in blue. 3, 4 carbons. So 4 carbons come in, and I form that bond between in this area right here. So what I'm going to do is I'm going to have that 4 carbon piece and just turn that into a bromide, right? Or iodide or chloride or any one of the halogens. That'll do this. All right, the next step. I need to deprotonate again. All right, and now I'm going to put the second piece in. So that's going to go in. I have, let's do this one in red. 1, 2, and then the ring. So I'm going to have the 5-membered ring and then 2 carbons hanging off of it. This carbon and this carbon. And again, I'll just make this a bromide just to make it easier. So that's going to do the alkylation of the second component. Now I got to get the elimination to happen. So I need to hydrolyze this. I'm going to eliminate the CO2. So I'll do a hydroxide hydrolysis. That'll take this ester to the acid. And then in the last step, I'll do H3O plus and heat to do the decarboxylation. And what I'm going to get from that is this. So these 3 carbon pieces. And in blue, I'll show the 4 carbons. 1, 2, 3, 4. And in red, I'll show the 2 carbons and then the ring. And that's it. All right. What I want to do is just real quick go through this one, showing you all the intermediates. So taking the acetoacetic ester. After the deprotonation, I wind up with the anion. Right? I've deprotonated, so that'll be step 1. After step 2, now I have that piece incorporated in, and I'll draw that in blue. Right? That'll go in from the SN2 displacement. I'm going to make the anion again. I'll put that up here. So after step 3, I'll have have this anion. And then after step 4, I'm going to have the alkylated piece. Okay, the next step, I'm going to do it over here. Step 5, that's the hydroxide treatment. That's going to hydrolyze the ester to the carboxylate. So I will have this as the O-, and I'll put my 2 groups on here. All right, and then the last step is going to be the acid treatment, which is step 6. That's going to protonate the carboxylate ion to the carboxylic acid, and then the decarboxylation is going to take place, and that will take me to the final product, which will look like this.